56. In the usual topology, suppose that A closure intersection A complement closure is empty set. Show that A is either the universe or the empty set. So let A be a subset of universe, and A closure intersection A complement closure is the empty set. So let's prove for two cases. Let's say that A is the empty set. In that case, we're done. We show that A is an empty set. So then in case 2, A is not the empty set, which implies that A is a subset of R. So let's say we have some element X that's in the universe. Then the goal, since we want to prove that A is equal to R, we want to show that these two are subset of each other. And we know that A is a subset of R, so we want to show that A contains R. And to that, we need to prove that this X is also in A. So we're going to do a quick prior contradiction. Let's say X is not A. Since X is not A, then we know X must be in the complement of A. And since X is in the complement of A, we also know that then X must be also in A complement closure. Since from the hypothesis we know that A closure intersection A complement closure is the empty set, A complement closure is a subset of A closure complement. This A closure complement is the open set, which means X must be in the open set of the usual topology. So X must be in some interval A to B. So in that case then, let's take the largest interval AB, that X must be in this interval a closure complement. So since in the usual topology A and B are not inclusive, we know that since B is not in the open set, then B must be in the complement of the complement closure, which is the same thing as A closure. So from the hypothesis, since we know that A closure and A complement closure is the empty set, then we know that B cannot be in A complement closure. So, therefore, B must be in the complement of A complement closure. So B is in A complement closure complement, and we know that that's an interior. So B is in the interior. But the interior is the open set. And B cannot be in the open since it is not being included in the open set. So therefore, we have a contradiction. Which means X is in A, which means A contains R, therefore X is equal to, A is equal to the real numbers.